Alright, so if we look at log base 5 of the cube root of 5, we're going to evaluate that using our properties of logs. So the first thing that I know is that the cube root is the same thing as having an exponent of 1/3. So I know that that's the same thing as 5 to the 1/3 power. So this is like log base 5 of 5 to the 1/3. And then my exponents rule, my power rule for logs, told me that I could roll that 1/3 down to the front. So this is actually like 1/3 times log base 5 of 5. And if we remember from last Wednesday, those then would cancel. And it would become 1, so it would be like 1/3 times 1. And 1/3 times 1 is just 1/3. So if we do another one, natural log of e to the 6th power minus natural log of e to the 2nd power. Okay, I know that I can roll these exponents down to the front. So I'll get 6 times natural log of e minus 2 times natural log of e. And then the second part of that was that this subtraction that I have actually becomes division when I combine them. So I get natural log of e divided by natural log of e, and they still have my 6 minus 2 out front. Okay, so then that cancels and just becomes 1. So I have 6 minus 2 times 1. And so what's 6 minus 2 times 1? 4. So this just simplifies to 4. Alright, then we got log base 4 of 5 times x cubed y. This is like 5 times x cubed times y. And so if we look at our our product property, that tells me that then I'm going to add them. So I'm going to add log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. All I did was just break it up into some different problems. And so then the only other thing we can do, the book has you leave it like that, but let's actually evaluate what a log base 4 of 5 is. So if you go into your calculator and go under your math tool, and then push up to where you're actually going to get to like the bottom of the list, you should see like log base B or something, I think. Yep, A, log base. Okay, so if you type that in, then it should ask you to fill in the rest of the numbers. So yep, so then 4 and 5, and hit enter, and what does it give us?
1.16.
Okay, so 1.161 plus log base 4 of x cubed plus log base 4 of y. We can't do the x and the y because we don't have it. Let's see if your calculator actually has it. Yours might not. All right. No, you don't have anything after the 0. So on these ones, because they're updated, which is why sometimes you have to change bases. If you go up, we have A as log base. You don't have A and B. So just use one of these for today. Okay. Alright, if we look at natural log of the square root of 3x minus 5, all divided by 7, we know that division actually equates to subtraction, so we're going to have the natural log of the square root of 3x minus 5 minus natural log of 7. Then I know that the square root is the same thing as having an exponent of 1/2. So this is like 3x minus 5 to the 1/2 power. And we still have the natural log of 7. And then my last property tells me that I can roll that 1/2 down to the front. So this becomes 1/2 natural log of 3x minus 5 minus natural log of 7. And we can leave it like that, or you can evaluate the natural log of 7 on your calculator. We'll just leave it like that for now. Okay. We'll do one more and then we'll be done. Alright, so 1/2 log of x plus 3 log of x plus y. Okay, well, I'm going to work backwards. So I'm going to take these multiples and I'm going to roll them up into being exponents. So then I would end up with log of x to the 1/2 power plus log of x plus 1 cubed. Those become my new exponents. And then since I'm working backwards, I'm going to take this and I'm going to make it a square root. So this is like log of square root of x plus log of x plus 1 cubed. And then the last step is that I know that I can combine addition to actually be multiplication. So this would become log of the square root of x times x plus 1 cubed. Okay, so we're just mostly going to be working with simplifying different logs to make them look differently, because that'll sometimes make them easier to evaluate. So you guys are going to do 241, 7 through 27 odd, 45 through 55 odd.